Simple Max Advance and Chessbots in C, Shlaer-Mellor Days 2024. Hello, I am Cortland Starrett of One Fact. This presentation is a mix of modeling and architecture. The early focus is on the application of robotically playing chess using an xtUML model. It then shifts to translating the model into C and the steps involved in accomplishing that. The modeling was motivated by the 2024 Chess Modeling Challenge. I will outline a few of the ideas I had for simple model extensions. I also wanted to supply a minimal show and tell to the xtUML chess modeling community for making a change hoping to give people a head start. The small delta change was delivered as a pull request to the public Git repository so people could see exactly what a minor change entails. You will see the implementation of the strategy that I chose as a model and witness the execution. We have two architectures which run the models. The first is the interpretive bridgepoint verifier. The second is Sierra Java. What does it take to add a third? We'll add C. What is the simplest strategy that might win? Starting from the teacher robot, which simply plays a random but legal move, what can we do very simply to make it smarter? What is the simplest change that might be able to win? An opening is a preset sequence of moves at the start of a game to place a player in a strategic or strong position. A good chess player has memorized several openings. It seems that it would be pretty easy to encode a handful of openings as pre-existing instance data of specification classes. This would make the bot smarter, but might be kind of boring to implement. A good point with this idea is that it can easily be combined with other ideas. The very simplest strategy I came up with was to choose moves from the list of legal next moves that always go forward. I actually implemented this and it did beat the random move bot. Better than moving forward is to move forward as far as you can. I named this strategy Simple Max Advance. It is what I submitted to the tournament. Alistair implemented Capture When You Can and then improved upon it. Here is the modified chessbot model in Bridgepoint. A new function package was added called move selection to house the domain function that advances the rank by the largest amount. The class diagram did not change. The structure of the state model did not change. The activity in the our turn state was changed to call the new domain function. Here's the our turn state activity in the OAL dialect. Notice that we still get the random move. I didn't change those lines. I only added a call to the Simple Max Advance function to change the selection. Just as an aside, notice the use of the zero timer duration idiom here, which is a subject for a separate discussion. Here is the Simple Max Advance function. It loops through all of the legal moves, looking for and measuring an increase or decrease, if black, of rank. It finds the move that has the greatest advance of rank. If we cannot advance at all, which could be the case if all of our pieces are pushed up against the opponent's end of the board, then we revert to selecting the random move. Here is the pull request on GitHub that I created so the community could look at the differences needed to make a small functional change to the chessbot. Something of a README is found in a comment on the PR. It even has a link to a replay of the bot versus bot game I'm about to show you. Here are the file differences in the pull request on GitHub. You can see that the change to the our turn state action is simply the addition of the call to Simple Max Advance. Here are the new package and new domain function Simple Max Advance. Some of you may recognize that the persistence format of this model is textual xtUML. This is a replay of the simple max advance xtUML model running against the teacher random legal move model. Simple max advance is black, the teacher model is white. See how immediately it advances pawns 2 steps forward. Then, as soon as a bishop is free to go more than 2, it takes off. And then the queen gets free to rumble forward. The next pieces that can advance more than 1 space at a time are the knights. Watch the knights jump all the way across the board. When no advance is possible, the algorithm reverts to a random move selection. The algorithm does push the game to the opposite side of the board very quickly. White was first to put the king in check, and then the black queen attacks, and again the bishop is open to stride forward. Nice how we end up with 3 queens. Checkmate. This certainly demonstrates that a simple strategy can beat no strategy at all. The Shlaer-Mellor method encourages separation of concerns, with the largest and most common 2 concerns being application and architecture. An xtUML model is a platform-independent specification of the application. A model compiler is an application-independent specification of a runtime platform. So we should be able to translate and run our model of chess onto multiple various architectures, which indeed we do currently Verifier and Sierra Java. How about a third? What does it take? I decided to attempt to translate the chess model into C using MC3020. Some background on MC3020. MC3020 was released in 1999, became open source software in 2014, and is still being used today. 3020 has been used by dozens of companies, universities, and high schools for various applications. MC3020 generates vanilla C and runs on anything with a C compiler. The chess model depends on a utility domain to obtain the list of legal moves. The Verifier and Sierra architectures bridge to a Java version of ChessLib. A C version of ChessLib was located and slid in pretty easily. The communication with the Lichess server was the next largest bit of work. For this, Levi and I updated the Lichess API he built for Java and added a file-based API to the C version of the generated model. This required some JSON parsing using a realized JSON parser called Jasmine. There were some MC3020 shortfalls. 3020 does not support the length operator on variable length arrays, so we needed a model change to maintain move count rather than using this length operator. 3020 has no support for assigning an array to another array, so we changed the return array assignment into a pass-by-reference function parameter. With this, the main branch, the simple model, ran nicely. To run Levi's more complex model, I had to fix a timer bug to support the zero-duration timer idiom. Thank you. I hope you enjoyed this presentation. The 2024 Chess Modeling Challenge has been really fun and resulted in the desired refinement of the tooling. Bridgepoint, MC3020, and Sierra were all made incrementally more robust. So Levi, mission accomplished.